Assalamualaikum warahmatullahi wabarakatuh. So today we would like to present our assignment for ECG353. But first I would like to introduce our group first. So first we have Nur Simran bin Rami, second Muhammad Afan bin Azhar, third Ali Fakri bin Alimuddin, and lastly we have Muhammad Muaz bin Burhan. For this video, we pointed three things. First, introduction. Second, circular water tank. And lastly, conclusion. Okay, for introduction, as we know, for this project, we developed the water tank. So we need to know the purpose of it. Okay, water tank's purpose is to store the water, and it is also used for drinking water, agriculture irrigation, fire suppression, and etc. Okay, for this project, we developed a groundwater tank to provide clean water for the industrial area in this project, and it has 10 meter of diameter and 6 meter of height. It is made of concrete. It also can contain approximately 500 meter cube of water. Okay, but to develop a water tank, we need to construct a borehole. So making a borehole is the most important step in building a water tank. Okay, the borehole's purpose is to extract water and other lights and other liquids like petroleum and gases, but it can also be used to determine the type of soil beneath the surface.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ali Fakri bin Alimuddin.
My name is Muhammad Muaz bin Burhan.
And today we're gonna explain on our model and about the soil profile of our site. This is the water tank model that we have been created. The water tank was supposed to have a 100 kilopascal load of pressure, and the radius of the tank is 5 meter. Right now, we were looking at our model that were planned to be located at Pulau Indah, Port Klang. As you can see, it shows the soil profile of the location that we choose. Here you can see that there's two boreholes. According to the site investigation report, the soil in borehole 1 and borehole 2 were topped with 0.3 of topsoil. The topsoil here is sand. And from 0.3 meter to 7.5 meter, the soil profile of borehole 1 is soft, clearly sealed, with the standard penetration test volume ranging from 0 to 2. The soil layer is soft, medium stiff, between 7.5 and 20 meters, with alternating layers of extremely clayey sand and light gray clayey silt, but it can be classified as medium stiff with SPTN values of 2 to 8. The soil is classed as medium gray clay with moderate plasticity beyond 20 meter depth, with SPTN value larger than 10.
Meanwhile, at borehole 2, in 0.3 meter depth, borehole 2 comprised a very soft clay sand layer with an SPTN value of 2. The soil layer is classed as moderately stiff beyond 0.3 to 20 meters deep, with SPTN value ranging from 2 to 10.
Based on an investigation of the subterranean profile and vertical stress distribution on boreholes 1 and 2, we can conclude that borehole 1 is the best purpose location for a water tank. The soil in the borehole 1 location is ideal since it has a sandy layer on top, and the soil is clayey 0.3 to 10 meter deeps. Because borehole 1 has a higher bearing capacity, it is more suited than borehole 2. Borehole 1 silt layer has a bearing capacity of 145 kilonewton per meter square, while borehole 2 clay layers has a bearing capacity of only 95 kilonewton per meter square. The higher the bearing capacity rating, the greater the load of or pressure that may be given to the foundation structure without destroying it or the structure that sits on top of it.
Borehole 2 is unstable because it contains clay soil at depth of less than 0.3 meter. Clay soil in general contain more space between its grain, allowing it to absorb more water. The soil will expand when it becomes soaked because of its ability to absorb water quickly. Clay soil is commonly referred to as expansive soil because the interlocking between particles is less when soil is extended. The density of the soil will drop as a result. Soil shear strength will deteriorate. In our calculation, the soil profile in borehole 1 is more appropriate for the construction of water tank based on the calculated vertical stress.
In conclusion, the objectives of the project are achieved. Subsurface investigation work has been done where all information are collected. It is one of the site investigation work that commonly applied for the proposed construction works. From all the data taken, the suitability of the site can be determined. On the first stage of the site investigation, which is subsurface exploration, is conducted by borehole activity. From that, the designing work can be done for the proposed development site. The soil profile was analyzed based on the borehole data and the SPTN value, which showing the type of the soil and the height of the soil. Finally, we can assess different stresses in soil caused by different surface load. Therefore, we are able to justify the suitability of the soil for the proposed project. Thank you.